Uh, Good morning to all of you, and it gives me immense pleasure to welcome you all for this 1 week FTTP, this Technovales 2020, organized by Cambridge College of Engineering in association with IET Local Chapter Pune and IET Pune Local Chapter. Uh, it gives me an immense pleasure to introduce today our speaker, Professor M.M. Narkhede. So let me introduce our today's speaker. Sir is having 8+ experience in the teaching field. He is currently working as an assistant professor in our Cambridge College of Engineering. Sir has completed his M.Tech from PGS Nanded and currently pursuing PhD in automotive electronics from SPPU Pune. Serving the various area of interest, such as the microcontroller, embedded systems, web and app developments. There are numerous kind of things. There's is having varieties of things we can learn from it, and without wasting much more time, I'd like to hand over session towards the MM aggressor. Sir, over to you. Thank you very much.
Thank you very much, sir, for your kind introduction. I take this opportunity to start with our day second from 1 week STTP program on practical electronics. This STTP is intended to be attended by lab assistants, technical staff, technical schools, and fellow technovators. Accordingly, day 2 content is planned as per the demand of industry and academia. That is nothing but Arduino. So there was a thought process why we have selected this topic as a major focused content in this STTP course. So I will shortly elaborate you through this thought process and why there is necessity of conducting these Arduino like awareness sessions in such STTP courses, specifically for technical staff. Let me guess your questions regarding this topic. These days Arduino boards are very cheaper and widely available pan-India. So earlier, most of the vendors from India were importing it from China, South Korea, North Korea, etc. But nowadays, it is being manufactured in India also. But somewhat, if we compare, right, there are mostly two different varieties available in these Arduino boards. The picture which is shown here is belonging to made in Italy original version, and that cost you around 1500 to 2000 range in Indian rupees. Whereas if we went for some local version, locally manufactured version of Arduino, you can even get it at 300 to 400 rupees. So whenever you look at this particular Arduino board, you may arise, there may be three questions in your mind. Why this topic? Why Arduino? Then what is Arduino, and how you are going to develop your things using Arduino? So with relevance to that only, I would like to focus. And also I would like to focus why there is necessity of these kind of Arduino boards in our regular day-to-day technical life. So these days, many engineering colleges, polytechnic and ITI schools also, and along with some school-going kids, right, from 5th to 12th standards, they are participating in various project competitions and science exhibitions. They are coming up with very innovative ideas. And one problem we have observed among those participants is that they mostly have ideas with them. They have so many things in their mind that they want to do this kind of thing, and then that should be automating some particular machine like that. but there is no exact way easily available for a normal engineering or polytechnic or technical student, right? In order to implement that idea in the most cheaper and simpler way possible. So that Arduino board we are talking about is the best solution for that. And looking at the wide audience here that we have got, right? So as and when required, I will also shift in between English and Hindi language. So meanwhile, if you are having any questions, you can also keep posted them onto our chat panels. Uh, okay, then let us begin with some basics of the session. So presenting you in front of you is our personal computer system. In that particularly, we are dealing with computer CPU tower, the one in most right side of this diagram. This CPU tower is responsible for connecting to various input and output devices. Most popularly, we are using a keyboard and a mouse, and some other devices are also there: LCD screen or monitor, speaker, microphone, and some supporting instruments or equipments we can also use, like a wireless internet router, or say sound uh, stereo sound setup, etc. And in industrial panels, we can also go for some data acquisition and other systems. The point of telling you all this is that this is a discrete computer based system where each and every part is having its own existence. Let us say this CPU tower box, so it is independent. This is a monitor, it is also independent, a separate part of the system, right? You can purchase monitor from one shop, and you can also purchase CPU tower from another box, another shop. And these keyboards and mouse, they can also be different model, make, and vendors. And similar things go with these kind of speakers and router-like devices. Now we know that these days computers have become very advanced, easily in our laptop and mobile phone also. Whatever we are using, that is also nothing but mini computer these days, right? So uh, what configuration we are having in our laptop? So it is 4 GB of RAM memory, 8 GB, 16 GB extendable. Then we are using hard disk of 1 TB, 500 GB, or even in many cases we are using solid state drives up to 1 GB. So these computer systems are very bulky. So they occupy a huge space in your office, home, and in order to deal with that, we have to invest space infrastructure. At the same time, being such a bulky system, it also demands for heavy power, because we need to connect to 30-volt AC main that is coming from MSCB to our home, right? So we need to connect it to that power supply, and accordingly, this system is bulky as well as power consuming. And needless to say, it is costly also. Normally, a good configuration computer costs around 30 to 40,000. Let it be laptop, or even mobile phones cost around 15 to 20,000. So though there is bulkiness, expensiveness, but still there is no limit to capacity, because we can do so many computations. Many softwares are there, like AutoCAD, MATLAB, Scilab, Xilinx. So such bulky softwares we are installing onto these kind of desktop systems and easily accessing the stuff. Same way, these systems, computer systems, we can use for multiple applications. To summarize with, I can at the same time type a Word document, I can prepare a presentation, I can attend a webinar meeting, I can watch a song, I can play movies, right? I can play games. So multiple tasks I can do at the same time using this computer, and those tasks also need to be very diverse in nature. Means typing a Word document and playing games both don't have any relation, right? So as a common sense, I'm not supposed to do that, but I can certainly listen songs and type a Word document, right? That is logical. So the point of telling you all this is that computers are very generic, and being generic, that is actually the disadvantage for most of the portable systems. Because if I am going to develop some kind of doorbell system, okay, so I am not going to install a complete computer at the back side of my door. That is not practical, okay, because Computer itself will cost 30 to 40,000, and then such a bulky structure I need to mount at the back side of door panel, and that too only to interface mechanism, right? That is, somebody is pressing a key from outside, and bell will ring it and alert the inside resident person. So that is not practical stuff. Similarly, many things which are mounted onto the moving things, right? Like speedometer. Let us take example about speedometer of your bike. So nowadays, all bikes, almost all bikes like Unicorn and then Honda, right? So they have got digital speedometer display onto their dashboard or um, uh, fuel tank upper side. So this digital speedometer is continuously displaying the speed of vehicle. So certainly this system can be implemented using computer also, but that doesn't mean that I should carry computer inside my car or a whole computer onto the fuel tank of my bike, okay? Because it is not feasible, not neither practical, it is too much costly, and it is of too much of inconvenience, okay? So instead, what is the solution in that case? There are many pocket size computers available. So I can talk about development boards, I can talk about Arduinos, I can talk about Raspberry Pi, I can talk about microcontroller in some extremely compact packages. Right? You might have opened your calculator sometimes, back panel of your calculator. So you will find that at the back side you will see a green circuit board, and onto that green circuit board just a black dot is there, right? So that black dot is nothing but an integrated circuit, IC chip. And that IC chip, inside that IC chip we can find nothing but our embedded system and microcontroller related circuitry. So through open eyes it is not visible, but it is still there, right? And the reason is those microcontrollers or some compact computers, right? They make our applications more portable. They make our applications less power consuming than before. And again, cost is getting reduced. So that is the exact philosophy why microcontrollers were evolved. Because like here is the example, right? A complete computer package, and the most important is the CPU tower, because we can replace a personal monitor, we can replace keyboard, we can replace mouse, but we don't expect that computer CPU tower should be replaced, because at the time of purchasing only we demand that shopkeeper to offer us a higher version, right? So that at least our next 4 to 5 years of task will be simplified. We should not find it necessary to upgrade our system and again. So this CPU tower is most important because it is responsible for all kind of data storage and then all kind of processing. Then the CD drive, that means the support for some external media like CD, DVD, floppy drives. So that is how. Then if we looked at the inside CPU tower panel, what we find, there is a there is a casing, and that casing is mounted along with different components. The mother of all is nothing but your circuit board, and that circuit board where my mouse is rightly pointing now, that is called as a motherboard. And motherboard is making it available, right? Or it is making interface available for all the individual devices. You will find various data cables, hard disk drive ID cables, and you will also find some kind of power cables arising from this motherboard to these individual devices. And all these devices might demand for different power again, because if you took example, this motherboard is having mounted different ICs, right? There is a microprocessor, Pentium 4, then Intel i3, Intel i5, Intel i7. So these microprocessor chips are very compact. They are having more than 400 number of pins. Okay, so these compact but highly advanced microprocessor chips are mounted behind this CPU fan, the cooling fan. And this microcontroller is mounted inside a socket, and that socket is soldered onto this motherboard, right? So this motherboard is the mother of all connections and peripherals. So that way it is making it available that all kind of data and power signals are properly distributed to individual devices like CD drive, hard disk drive, floppy drive, etc. And at the same time, it is also taking care of different voltage levels. Let us say your processor, which is mounted onto motherboard, is demanding for 3.3 volts for its successful operation, and your hard disk drive may demand for 5 volt DC. Then your CD writer may demand for again 5 to 7 volt DC, and there might be a CPU fan here, which is mounted above processor, and this is the outside CPU cooling fan, which is mounted at the back panel of your CPU tower box. So these are nothing but DC motors. Okay, so these DC motors are operating at 12 volt DC. Now, inside one CPU, there are at least 3 to 4 different voltage levels, right? 3.3 volt, 5 volt, 12 volt, 9 volt. So it is not possible without the support of this SMPS panel. So in our CPU tower, there is a SMPS switch mode power supply unit, and that switch mode power supply unit is responsible for taking input from our 230 volt AC mains, and then it is distributing it in various different voltage levels. Those are again further distributed via motherboard to individual components. So I guess this much basic was essential for understanding what exactly we will be going through in upcoming few minutes. The point to understand that a computer is nothing but a computational device in which some kind of program is there. We can call it as an operating system. In my laptop, there is a Windows 10 operating system. Somebody will have Windows 7. Somebody will have Linux, right? So these different operating systems are nothing but programs of this computer. So in hard disk, all these kind of operating system and programs are stored. And when computer is switched on, that operating system starts loading. Okay, and when it is completely loaded, then only onto my monitor screen I get a complete desktop panel, so that I can then click on start menu. I can go to my computer. I can play a movie. Okay, I can play games. I can listen songs. I can do anything once the computer is logged in successfully. So in order to avoid the bulkiness and expensiveness and somewhat making it more flexible for low cost applications, now we should move towards microcontroller, right? This was a microprocessor based system where each component was having its separate existence. Means hard disk is different, processor is different, then RAM is different, then again there might be different chips, right from real-time clock, BIOS, everything is different. But all these being different again is bulky, right? So that is again a disadvantage. So the solution in front of you is nothing but a microcontroller, and it is very much important for technical schools and polytechnic institutes also to get started with this kind of microcontroller programming, because there is a huge demand in embedded industry and automotive industry for the engineers who can troubleshoot ECUs, who can troubleshoot control panels, and as and when required, they should understand the workflow of how the system can be interfaced with the software with the help of some cables and drivers. So if we are having this essential knowledge of microcontroller, then this serves as ABCD, right? If we know what is A to Z, right, then we can form small sentences. Then if we know how to form small sentences, we can develop essays and we can give speech, right? So these are as good as sequential development processes. So that is why these microcontrollers are important. To be very specific, microcontrollers, the name itself suggests, right? A micro plus controller. Micro means a small and controller means which controls the dedicated task according to the user's choice, right? So that means we can think about, I'm interested in setting a timer for, let us say, 5 minutes. And after 5 minutes, that timer should get elapsed. Once timer is over, it should alarm, okay? Or it should glow some LED, light emitting device. Or it should sound some buzzer. It should give me some signal onto LCD screen. Now these are very small systems, right? So I should not invest entire Pentium core or Core to Duo quad core computer for that simple task. Instead, there is just a 90 rupees microcontroller 8051 and some essential circuitry, resistor, diode, capacitor, etc., crystal oscillator. entire system can be built within 200 rupees. So that invests very less cost, and at the same time the size is very compact, because we are nowadays more encouraging the use of portable and long running products. Okay, so even we can take example about our mobile phones. Being smartphones, they are mostly discharged within a day, right? So that is why in embedded and portable systems, low power consumption is extremely desirable parameter. Then their size should also be small, right? And if students are developing something creative and innovative for the society, then also microcontroller serves a vital role. Why? Because if they started directly developing on a computer, then system would not directly give them a product, right? So it will be just confirming that this is how the product may work, or this is going to be just a prototype version of the product. But if they want to use it directly on real-time basis, directly in the system where they want to control some parameter, then there is no option to microcontroller, and many other options are also there. So exactly understanding a microcontroller, they are available in various packages. Two packages are shown here. One is a dual inline package and another one is a SMD package. Dual inline, a simple thing, right? Dual means there are two lines, right? One is this side and other is back side. So, and all these IC pins are inline, okay? They are sequential. And that is why it is called as DIL packaging. And dual inline packaging is the most basic version of many microcontroller ICs which are available right from 8051, ABR, then PIC, and they are necessarily through hole modeled. Okay, so means for a circuit board you have to drill holes, and then in those holes you have to then insert IC, and then from the back side you have to solder each and every pin, so which will make that IC fixed to the circuit board. On the other hand, there is SMD package, which is most convenient and widely used in today's date in many electronic gadgets. What is so special about these surface mount devices is that it is highly compact. So again, it doesn't need circuit board to be drilled at various pin positions, right? Instead, these pads are directly kept upon the footprints of IC, and then they are externally soldered from again top side only. Okay, in case of DIL or dual inline packaging, we needed to solder from the bottom side of PCB, but here in case of SMD package, we are keeping solder balls onto the top side itself. Again, it is easy to desolder also. So there are other advantages also for the SMD packages. So exactly when microcontrollers are very evolved, right? So people started understanding their various applications, and then they started developing development platforms. Let us say if I'm just going to some electronic shop and then I'm purchasing this Atmega 328 IC. So it is some 28 now. This is some DIL package, and then I purchased it. But only this IC I have purchased. Okay, so I cannot do anything with a single IC. I need a complete setup to be interfaced onto either a breadboard, or then separately I need to design a printed circuit board. Then I need to solder all individual components, including this IC, its programmer circuitry, its power supply, and everything. And then only I will be able to go ahead. Okay, I will make it simple. In turn, it is very difficult to directly begin with this kind of raw level single components like microcontroller, right? So to make it easy, we are having solutions, Arduino boards, right? So these boards are making us available everything: microcontroller, is reset circuitry, clock circuitry, power supply, regulator, etc., etc., right? And one thing that is different in microcontroller from earlier computer-based systems is that in computer every component was different, right? Hard disk was different, ROM memory was different, RAM memory was different. Here everything is mounted onto the single silicon wafer slice. Why silicon? Because it is semiconductor. Okay, so everything is mounted onto a single silicon semiconductor slice, and that is again coated with this kind of plastic material, black color plastic material, so as to get it well protected from environmental noise, vibrations, and further damages like temperature, humidity, etc. So then it takes a form of IC, right? And that is what making microcontrollers more compact, because there are no individual peripherals. whatever where the peripherals along with CPU, all these timers, counters, input output blocks, everything is now combined, and it is transferred onto the chip only, right? That is making it low power consuming, compact in size, easy to use, portable. So they contain everything including CPU, memories, IOs, RAM, etc. onto the chip. And easily we can find microcontroller applications in day-to-day life. Let us take an example of our smart washing machines, microwave ovens, digital timers, then mostly burglar alarm systems. Those are used in home. Then we can use some automatic garden water pumps, right? So these are the small examples where our systems or products are working as per some logic, right? Let us say somebody press the key from outside, and then according to my setting, different ringtone or different alarm bell is ringing, right? Sometimes there is a Gayatri mantra, sometimes there is some song from movie, or sometimes there is just a siren horn. So this is programming, right? We through the programming we can configure it. Let us again take example of digital thermometer. A very cheaper version of thermometer is available these days, right? The end cost is within 20 rupees only, and that is again sold in the market with a margin of 5 to 10 rupees for some 25, 30, depending on the again customer and market scenarios. So these digital thermometers are again the microcontroller based systems only. So what these are doing, right? So they are measuring the body temperature using some sensor, and microcontroller is also there inside those systems, which is accepting that temperature and converting it to some voltage, and then displaying again in the form of some screen. Okay, so we can say that digital thermometers are very useful. They are very low power consuming. They are again very much easy and suitable for use. Okay, so and most of all is dedicated. That means I cannot expect my washing machines to play songs for me. Okay, that is beyond logic. I cannot again expect my uh, digital camera, right, to play movies for me, or I am not able to play games on it, right? So that is also impractical. So the point to understand is that microcontrollers are intended for dedicated tasks, right? So it will only do what it is supposed to do, right? Washing machine will only wash the clothes. Then smart ion mechanism will only be used for the intended job. I guess that is essential understanding of the difference, right, between a computer and microcontroller. And these days microcontrollers are very cheaper, so easily within 100 to 100 rupees you will be getting most of the ICs. But let me tell you, in market there are more than 1,000 different variants available, and it depends on our requirement. Okay, what is our end product? Okay, as a designer, as a school student, or as a engineering college student, right? What is my end project, and then what are its requirement? How many pins it is needed, right? So what should be the power supply that it should operate upon? What should be the approximate size of my product? So everything I should have fixed in my mind, and then only I will proceed with the proper selection, because in market there are 1,000 plus vendors available, and many popular big companies are there: Intel, Atmel, Renesas, Reynolds, Infineon, and then again our Philips, right? So many Freescale, many such vendors are there. So understanding now the topic, core topic, because slowly we are now moving towards Arduino. And as per our planning, we are trying to cover most of the basics in our first morning session, and in the second session of today, we will be doing something onto the practical IDE stuff, right? So practical approach we will be trying to cover upon in the second session. So right now, just understand the thing that where my mouse is pointing, right? So these are discrete ICs, and each IC is used for separate purpose. We can take example of this central IC, that is for microprocessor. It can be say i3, i5, or i7. This is a RAM IC. Then this can be the program memory, and this can be analog to digital converter. This can be oscillator chip. So in this discrete chip-based system, or this is a general microprocessor-based system, everything is having its independent existence. But when we are going to design our microcontroller, we are integrating each and everything together onto a single silicon wafer slice, and that we call it as a microcontroller. And then we can take pins outside, right? So that we cannot directly access at this point. Okay, it is very compact. To the microscopic view also, most of the times it is not visible. So for external interfacing with our circuit, we are having different IC pins and pads made available from the outer corner, and that entire structure is again coated with some black plastic. Okay, so now this is a microcontroller, and inside that microcontroller, whatever we have implemented or whatever we have embedded, that will be our main microprocessor block diagram. As you can see in that main block diagram, this CPU is serving as a captain, a boss of entire system, governor or kernel. So this CPU is responsible for commanding to other peripherals. CPU is processing, okay, central processing unit. Whatever program we have fed to our system, that program is stored in a program memory, the rightmost where my mouse is pointing. So the program might be of 10 to 15 lines, okay, or it might be more than 10,000 lines also. It depends on us. We are developers. So what is our end application and what are its demands? According to that, we will be designing a program. Okay. So whatever program we will design, that program will be stored in a program memory, and when CPU will be interfaced with that program memory, by default it is interfaced automatically. So inside IC, so this CPU will continuously fetch each instruction one by one from this program memory. So instruction 1, instruction 2, instruction 3, instruction 4. So all these instructions will be fetched one by one, and then they will be executed. And then when required, the output will be made available to individual input output ports. A very practical example, we can talk about a newly born child. Okay, let us say a newly born child having age as 15 to 20 days. Okay, now that particular newly born kid may not understand anything. Okay, that kid may just look at you, but it may not really interpret, right, what you exactly mean. Now it is your role as a parent. You go on continuously teaching that kid, particularly this is the thing, this is called as mobile phone, this is called as computer, this is called as pen. Okay, so you teach each and everything to the student, that kid, and over the time, after 1 month, 2 months, 3 months, or 1 year, that kid starts identifying the things. Okay, why? Because while teaching to that particular newly born child, throughout the time, we are continuously programming something, right, in his mind. Okay, we are training the brain. So the same structure of human brain, right? So whatever data we perceive, that is somewhere getting stored in our brain, and through that stored data our brain is interpreting it. Okay, so by looking at some particular scenery, we are responding. So why this is happening? Because our eyes are perceiving data, our eyes are sensing data, and then based on that sense data our brain will process, and accordingly we will respond. If the scenery is very beautiful, we will say wonderful, beautiful, wow, like that. So that is nothing but a reaction or output of our brain processing system. So similarly, the things happen in microcontroller. We are writing the program in computer, and then via some setup, we are transferring that program into program memory of microcontroller. Right? You can also think of your CD writing procedure. Right? You are having a song or a movie of 1 GB, and you have stored in some D drive of your computer. So most of the time, while sharing that movie with your friend, what you will do, you will attach some kind of pen drive, or you will insert a blank CD DVD in your CD writer, and then you will write that movie content onto DVD, and then you will share that DVD with your friend. So similarly, whenever we want to transfer our program to microcontroller, we are forming a setup like this. We can find here is a computer, and that computer is connected via a cable with this development board. Right, here we go. This development board I was talking in earlier slide. Because this single microcontroller, if I purchase from a shop, I cannot proceed directly with my end product. Rather, I need some platform for its experimentation. right? Shopkeeper will give me anything. I'm paying money, shopkeeper will give me even separate Pentium 4 IC. But what am I supposed to do with Pentium 4, right? I will need a motherboard. I will need that IC to be inserted in processor socket. I will need a RAM memory. I will need a hard disk to be interfaced. And all these parameters need to be powered by SMPS panel. Entirely when this connection will happen, then only my computer system will start. Okay. So this is how our development board is easy to understand, because there is a central socket, zip socket, or it might be directly soldered onto the board, and this is main microcontroller. But in order to support that microcontroller, we need a crystal oscillation circuitry, we need a power supply, we need switches, we need some LEDs to show the status that microcontroller is receiving power or not. We need so many things, right? So this development board is nothing but a circuit board available in market for different microcontrollers. You will be getting for AVR microcontroller, you will be getting for 8051 microcontroller, or ARM Cortex, anything, right? So the point is, this is computer, and according to the microcontroller, there is a software. If I am programming Arduino, then I will need Arduino compatible software running onto my computer. If I am programming with 8051 microcontroller, then I will need KIL version, right? KEIL. There is a very popular KIL IDE for 8051 related application. Rather, if I am programming with some Freescale microcontrollers, I will need a Code Warrior. That is nothing but a software which I should install onto a computer-based system. So this is how, again, like we are programming brains, like we are transferring instructions to the newly born kid. Here we are transferring program into the microcontroller's program memory. So sometimes the program memory is also called as a flash memory, because we may write program in one language. Now it is the role of software to convert it in a compatible version, right? So means, suppose if I went to some Japan, okay, and I'm not knowing Japanese language, but what assistance I will get there? I will be speaking with someone who is working as an interpreter. Okay, so I will be talking to that interpreter person in English language. Now that interpreter will translate my English language into Japanese and will communicate further. So that is nothing but interface. So this computer, this software and this setup is making us available with that interface, right? So using this, we can program microcontroller. Using the same, we can erase microcontroller, like a brainwash. Okay, we can teach the thing and we can again brainwash sometimes, or we can just forget it over the time. So same things are happening with the computer. But important and really amazing fact is that most of the times these microcontrollers are offering you more than 10,000 erase and writing cycles. Means I'm telling you example of PIC microcontroller developed by Microchip Corporation. Okay, so that PIC microcontroller can be erased 10,000 times and again reprogrammed. Okay, so that much of endurance is there. And this is nothing but development board that I was mentioning. This is main microcontroller, and that microcontroller is main controlling element, and it may be AVR. In case of Arduino, we are using AVR at mega chips. Okay, so at the right side, I am also showing the pin diagram. For most of the people having uh, polytechnic and ITI backgrounds, technical school background, this pin diagram may sound complicated, right? It may be very difficult to understand in the very first look, but eventually, if you are going to develop some kind of application, you right now just need to understand the thing that these are pins and each pin is having certain function. Okay, now according to our application, our product, right? We are using particular pin. Say this is like a pin number 7. If I'm talking about 7 is VCC. VCC means a positive power supply, 5 volts. Ground is 0 volts, right? That is self-explanatory. This is again PB6, PB7. These are general IC pins. Okay, so means if I want to connect LED, so I can connect LED between this PB6 pin and ground pin, because LED is having two terminals. One is anode, another one is cathode. So anode is connected to positive supply, so VCC, and cathode is connected to negative supply. So it may be PB6, or in a reverse manner also I can use it. I can connect cathode to ground and I can connect anode to some PB6 or PD4, like general purpose input pin or output pin. The point of telling this is that these are microcontrollers, and this is development board, which is making us available with different uh, generally used blocks, right? Say we are using keypads in most of the products and projects. Many students in science exhibitions, when they participate, they are developing some home temperature logger system, right? So for that home temperature logger system, they can easily get started using such kind of Arduino or development platforms, right? So there is availability of sensors, there is availability of LCD display. So if they return a proper 10 to 15 lines of program, and if they transfer it to microcontroller, what this development board will do, it will sense the temperature using temperature sensor, it will process the data, and it will display it onto the LCD screen. Means all things that you need, they are available at the same place. So it is reducing your development time, right? If earlier 5 to 10 years before, right? So mostly everybody needed to develop all these things using breadboards, right? Or they might need they were needed to develop this kind of circuits on their own, or using some zero or dotted PCB boards, right? So it was a time consuming process. But now these development boards are already available. Moreover, their schematics and PCB footprints are also publicly made available by some companies and organizations like Arduino. So students can use it. Students can easily test their product idea onto this development board, and then further, if the idea is successful, they can transfer it to some product which can they can again go through some commercialization or exhibition process. So just 2 3 days back, I heard news, right? That one particular student developed a system, weather monitoring system, in 500 rupees, and for that he used the same Arduino board that we are conducting the session, right? So that Arduino board was interfaced with some humidity sensor, then temperature sensor, and some basic environmental sensors. So that board was accepting the data from those sensors, and it was processing and sending data to some server. So that is simple, a weather monitoring system, and the entire system was costing around 500 rupees only. So there is availability of some supporting components also along with development boards. Some programming cables are there. Most of the time there are power adapters, right? So it is expected that you can explore the market, or you can explore through some online shops also, Amazon. You will be getting these microcontroller development boards or Arduino combo packages at much cheaper rates. Without investing much time onto basics now, I hope that you have understood why we are going to learn Arduinos and what was the background behind Arduino board. So it is very popular in the different technical institutions, and it is offering you the quick prototyping. So your time to market or your time to exhibit is reduced sharply. Means suppose any diploma students wants to participate in DPEX competition. It is very popular competition in Maharashtra. So in that DPEX competition, one particular earthquake detection system, suppose we need to develop. So now using Arduino, the task will be very simple, because there is availability of some piezoelectric sensor, okay, or vibration sensor. So we can purchase that vibration sensor for some 100 rupees. Then we can purchase Arduino board from some 400 rupees, and then you can purchase some kind of buzzer, okay, 5 to 10 rupees only. So using just this much of investment and just some batteries and all that, 20 rupees, so you can develop the entire system within 400 or 500. So earthquake detection alarm, okay. So the task is simple. So these Arduino boards are very simple to use by teachers, students, or our fellow innovators. And entire whatever the complications were there in microcontroller, I told you one thing, there are 1,000+ microcontrollers available in worldwide technological eras, right? So, or technological areas. So out of those 1,000 microcontrollers, which microcontroller I should exactly get started with for my end application, right? So that is very difficult task to decide. So rather we expect that prototyping or basic feasibility testing task should be developed onto these Arduino boards, and if it works successfully, then we can move towards those dedicated microcontroller platforms. And there are some advantages also using these Arduino boards. They offer cross-platform development tools, right? You can work on most of these offline softwares also, like MS Office, VLC Media Player. At the same time, if you don't want to install bulky softwares onto your system, there is a solution. You can work on websites only, right? Using web-based editors, using web-based circuit simulators, you can start developing it. One important thing I would like to mention, in our second session of day today, I will be focusing on to use of web-based circuit designers and simulators for designing Arduino circuits and simulating them as per our program. Some basic scenario we will be covering, but that will again give you basic idea about how Arduinos are suitable for our use even without investing a rupee. Okay, so again, very clear programming environment is there as compared to other microcontrollers. Program is almost like C programming, the most high level programming language, basic high level programming language for the day. And moreover, on hardware and software level basis also, Arduino boards are open source. That means, of course, they are asking for a contribution if we try to download the softwares using their website arduino.cc. But as a student or innovator, you can always download it freely and use it for any non-commercial purpose. So these are the essential softwares and their resource links. So I request audience participants to kindly take a screenshot of this and keep in your record. So for offline softwares, I will be mentioning of Arduino IDE that you can download from arduino.cc, a very popular mother website of all these Arduino related stuff, because the website is being managed by Arduino community itself. And there is again a Fritzing software. So this IDE, which I'm mentioning at the top, right, integrated development environment, this IDE is making us available programming environment. Okay, it means everything that we are doing in a computer, right, as far as program is concerned. Program can be very simple, LED toggle, okay, or program might be say LCD display, program might be say sensing something and processing, okay, giving output to buzzer. So this programming I will be doing in Arduino integrated development environment, Arduino IDE, and then there is second software called as Fritzing, which helps me to design the circuit for Arduino related boards and supporting shields. And using a very easy to use platforms like Fritzing, now our development time again gets reduced, right? You can export that circuit easily into PCB footprints also, and you can get it manufactured by any professional fabricator, PCB fabricator. That means students can directly develop industry standard products just by sitting on a machine, your regular computer machine. There are online softwares also available, web editors of Arduino itself. There is an online simulator for Arduino based circuits and some other electronic circuits also. It is a very growing community these days, Tinkercad. So we call it as tinkering. Okay, so let's go on tinkering some circuit. So that is going to be a very funky stuff. And then again, circuit prototyping platform is also there, web-based circuit prototyping that is happening at circuito.io. Right. So circuits.io is different website that is also useful, and this circuito.io is specifically I would like to mention for Arduino. So I hope you have taken a screenshot of this, and I would like to proceed. So far we are only trying to cover Arduinos. Meanwhile, if you are having any doubt, you can just go on asking in chat panels as and when I get attention and again I get a pop-up, I will be trying to answer that question. So let us actually begin with Arduinos now. So I'm very sure for most of the polytechnic students, technical staff, because mostly technical staff need to maintain these kind of things in their electronics laboratories. Many colleges are procuring Arduino combo kits, right, in their laboratory. They might be starter kits to immediate and advanced kits. Many colleges are procuring just Arduino Uno and Nano boards for easy experimentation of some mechatronics or robotics related practicals, okay, or digital electronics related subjects. So these Arduino, there are many different Arduinos available. Arduino Uno, Nano, Mega, then Arduino Leonardo is there. So many different Arduinos are available, but this Uno, which I am mentioning here, is the most popular and widely available anywhere in India. Okay, so easily at any local shop, local electronic shop, you will be getting Arduinos within some 400, 500 rupees, right? So if you are buying it for uh, wholesale, right? So for college laboratories, a combo pack of 5 or 10 different Arduinos, the cost may again reduce to 300 rupees. So this is the Arduino schematic that I'm mentioning, major pins and their functions. So for most of you right now, just focus. I suppose you to just focus upon the rectangles and the description which is mentioned there. So the most important is USB plug, because what we have understood, we are going to write a program in software, and then that program we are going to transfer into IC. Where is IC? Where currently my mouse is pointing. Okay, so in order to transfer that program from computer to IC, we need some interface, and that interface nowadays every computer laptop is having USB port. Okay, so through this USB plug we are making establishment of that interface and we are transferring our program. And Arduinos are very user friendly. Okay, even if you forgot to connect these power supplies, most of the time it will receive both the program as well as the power from USB plug itself, right? Then this IC is mounted onto the zip socket, and through this printed circuit board, this blue color printed circuit board, all these circuit connections are made available as an external pin through these headers. Okay, so because it will be difficult to interface directly at this point of uh, section, right, where my mouse is pointing, but it is easy to interface our circuit here, right? We can insert LEDs, we can insert connecting wires, we can insert external shields. I will tell you what are shields. Okay, so just understand, this is a USB plug, this is external power supply jack. 2.1 mm power supply jack is there. So using some DC power adapter, we are supplying power. 5 volt, 9 volt is enough. And this is power regulator IC, because this microcontroller demands for 5 volts, okay, or sometimes 3.3 volts. So our 5 volt DC power supply will be most of the time will be then processed, and then some regulated voltage will be then supplied to microcontroller, so that microcontroller will not be damaged. Because if we supplied maximum more voltage, microcontroller will get burnt. Okay, it will get overheated and burnt. There are some other components also, like this is reset button. Like every computer is having restart button. Okay, if our computer gets hang, what we are doing, we are just pressing that reset switch and computer entirely gets restarted. Okay, so this is so simple. If we want to reset our microcontroller at any point of time during our execution, just we have to reset the button. Resetting will not erase the program, it will only make that program to be executed right from the first line of code. Okay, if there is 10 line of code you have written, so first to 10 lines will be again started for execution, right? So this is a reset switch, and this is a crystal. Crystal is again playing an important role. Why? Because at